Good. Yeah. How's everybody doing? Super pumped to be done with the lab. About that? Are you pumped to be done with the lab? It's done. Yeah, it's over. Don't have to do that anymore. Somebody was asking a question.
How does your game end?
How does my game end?
Yeah, like my game doesn't end.
So I made a screencast of me walking through the lab and building it out. And the first couple of times I run it, after I finished it, it runs and it looks like it's running forever and ever. And I'm like, oh no, something's broken. And then I go back and I like read through the code. And there's like 5 minutes of the screencast where I'm reading through the code, trying to figure out why it's not finishing. And then I run it again and it ends. And I just hadn't given it enough time. So it could be that you're stuck in an infinite loop. It could also be just that it's a game of luck. So it could take, like, I ran it once and it took like 4,000 rounds. And I had to sit there for all of those.
You check my game once for like million rounds. Like,
Never ends.
I haven't.
So, I don't know. I don't know. So I can take a look at it after you've submitted it, but it's likely that you're in some kind of infinite loop. And where I ran into that was in the logic of like taking cards from my hand, displaying them, and then when someone wins, like collecting those cards to a user. That seemed to be where I ran into that, or is like a likely place to run into that. But yeah, so questions on the lab. How are people feeling about it? Yeah. All right.
I can't say I was successful.
So give me some details. Give me some feelings.
Interesting lab.
Interesting.
The sense where you really had to break, if you're used to playing the game, you really had to break it down.
Yeah.
And that part was interesting. I was like, oh, so it's this now, it's this.
Yeah.
But there was a lot of pieces that I just don't realize.
Yeah. So that's really good point. The challenge in the lab is two-part. One is, what's the syntax for an object? Oh, I forgot. I hope I wrote that down in class. The other part is, how do I write a program based on this two-paragraph description of a card game? Yeah, that's a great point. It's tough. How did you break it down?
I had to break it down into 3 parts.
Part one.
Part 1 was to the deck, building the deck.
Yeah.
Part 2 was dealing the deck. And part 3 was playing the game. Playing the game kind of became a function. And I was like, oh.
One big function.
I was like, oh, yeah. I was like, this isn't right, but I'm just going to keep rolling with it. I'm running out of time.
Totally cool. How did other people break out the game? Into various components.
I broke up into card and deck.
Card and deck.
I actually did the gameplay on the index file, and then just did it that way.
Great. Sounds perfect.
And I didn't do it, but like I did something that like resembles what maybe what we did.
Awesome.
I got really caught up on the war part itself, what you were just saying. Like,
Oh, the tie.
I like got to the point where I could, and the reason I was having a problem was accessing like this dot score from deck in my index. I can't even figure it out. And
Okay. That's fair. Yeah. So that has to do with scope.
Yeah, I just don't have time to like troubleshoot.
Totally fair. Totally fair. Okay. So let's see. I thought I had the lab up somewhere. Maybe I did not. But I have it here. Okay. So I pushed a solution, which is in this solution folder. It's important to note that this is a solution, not the solution. So I broke mine up into, I have an index.js file, which looks like that, and that means that it's outdated, and that's not good. Let's do this. C4 less. Nope. All right, there it is again. Cool. Okay. So this is my index.js file, and this is all it is. I abstracted out the game logic into an actual game class, and meant to get to a point where a lot of the logic of like comparing who won, or like it's war, like we have to do a whole nother round, all that stuff, would be part of the game class. Instead, I just have one monolithic function called play where all of that exists. But this is kind of nice, and this is really what drove me to want to do it, is my index.js file was huge because it had all the game logic. And this way I could kind of extract that out a little bit, and then this looks a little bit cleaner. It's kind of like sweeping the mess under the floor until, or under the rug until you can actually get to it. So prompt.get, I'm going to get the player 1 username, the player 2 username. Then I'm going to pass those to my player class and create 2 players, and then pass my players to the game when I instantiate an instance of my game class. So that's all I'm doing there. We'll go through, let's see, card, deck, outfit player, and then we'll do game in that order. So card, this should look almost exactly like, if not exactly like, the card class that we built in our exercise before doing the lab. I don't think I made any changes actually. I'm using an object to hold the scores so that when we pass in a rank, right, this rank, we can think of this as like a variable and it's holding a string. That string is going to match to one of the properties, keys, excuse me, in my object and return the property. So this, if I pass in ace, the string ace as rank, this is going to look up ace in my rank scores object and evaluate to a 1. So then my score for this score is equal to 1. And that's just like a clean, this is called object lookup. It's like a clean way of doing this kind of thing. So that's my card. The next one, that did not work. The next one here is my deck. I have to require the card class so that I can build my deck. If you think about a deck, it's really just a bunch of cards. So yeah, we need our cards. And by and large, I think this also really looks a lot like the one that we did in the exercises leading up to the lab. So my first instinct was to create an array called this.cards, and then create something like this.createDeck, so that down here, say if I were actually building on a deck, I would do something like var testDeck equals new deck. And then in order to actually have a deck of cards, right, like an array of instances of my card class, I would have to do something like testDeck.createDeck, and then I could start using my deck as a deck of cards. Well, I'm lazy and forgetful, and I knew as soon as I saw this, like, I'm going to create a deck, I'm going to forget to do this, and then something crazy is going to happen. It's going to take me forever to figure out what's going on, so I'm not going to do this. Instead, maybe there's a way that I can just do testDeck equals new deck and then have a deck of cards. Is everybody following this?
No, because I don't see that in your code.
Oh, so right here. So here I just have a function inside my class. This function is exactly the same, more or less, as the ones that we did in the exercises. It's just going to create a deck of cards. And it's going to return that deck of cards as an array. So cards is equal to an array. I'm going to push each new card into that array, and then I'm going to return that array. And then when I create this.cards as the property on my deck class, I'm just going to call that function. So now, every time I create a new deck or an instance of this deck class, this .cards is already an array populated with cards. Does that make sense?
But cards was an object.
Cards is a class. Yeah, so they're objects, but it's a class.
Yes. So you nested a.
So right here,
Deck and array.
yeah, deck is an array.
Okay.
This or deck.cards, right? A deck is really just a collection of cards. It has its own functionality and property, but like if you think about a real world deck, right? It's 52 cards stacked on top of each other. Unless you're doing a 52 card pickup with your little brother or little sister. Cool. Yeah. So then I just have my deck automatically stored in this .cards, and then the functionality for dealing out a hand of cards, I attach to my deck. So I can do something like var test deck equals new deck, and then player one dot hand equals test deck dot deal hand, and it'll deal out 26 cards to that player. We had like a deal hand function in one of the exercises before. This is almost exactly the same. But thanks to Marvin for mentioning splice, I'm using this splice array method. There was one gotcha with the splice array method. Did anybody run into it? Yeah, it returns an array. So splice, I think, is most often used for removing more than one item from an array. Say, starting at item number 4, we're going to remove items 4, 5, 6, and 7. So then, since we've got more than one item, we're going to return those as a list themselves, as an array. So this .cards.splice with some random index is going to return an array, and that array is only going to have one card because we're only asking for one. But this is going to be an array. So if I just push that into my hand to return array, what I end up with is answer return is an array. Inside it, I have 26 arrays. And then inside each one of those arrays, I have a card, which I do not want. In no world do I want that. So the way I did that is I just got the first item from the array right here. Since I'm only getting one item, I'll just get it right there, and then I'm returning that one card. Does everybody follow that? This really only applies if you use splice like this. Here, I'm getting the return value of splice and saving that as a card. If I were pulling a random card from this array and then splicing it out later without capturing that return value, then I wouldn't run into that issue. Or if I wasn't using splice at all, I wouldn't run into this issue. Is this kind of like what other people did for their deal hand functionality? Nope. Nope. What did you do?
Stack Overflow.
You didn't copy and paste from Stack Overflow, did you?
I did. I copied a function shuffle array.
No. Did you? But wait, let's give him a chance to redeem himself. You pasted the function into Sublime or Atom, and then you read through it line by line, made sure you understood every little thing that function was doing.
I mean,
You edited it a little bit because it wasn't doing exactly what you needed, and then you moved on.
It basically does, like your math.random, like that's the biggest part of it. But I used it to randomize the array, and then I used, so like I didn't use it to like,
Yeah. That's cool.
yeah, and it, maybe that's why I run forever. I don't know.
No,
Maybe it's truly random.
so you're taking this, you're coming at this from like a slightly different angle, and that's really, really cool. So what I'm doing is taking my array of cards, my deck, and getting a random number and then pulling out a random card. So, kind of like fanning out the deck and being like here, 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 26 times, and then like, all right, here, player one, that's your hand. What you're doing is taking that deck and randomizing the order, shuffling it, yeah. and then just pulling the top 26 cards off.
Yeah,
I think
that's
those
exactly
player
what I
one.
did. I used slice to pull 26 cards, and then the rest of the array I assigned to user 2.
Yeah, that's really
Can you
cool.
go through more specifically what this line 27 is doing?
Line
Like, slice is
27.
weird, and I don't.
Okay. So yes, this is pushed. So if y'all do get pull in your lab, you should get this. Or get pull upstream master, most likely if you set the upstream. Okay. So we're gonna ignore what Fadon did, even though that's really cool, and that's definitely one route that you could have taken. What we want to do is pull a random card from our cards array. So we need a random index. So we're going to do that with math.random times the current length of our card, of our array. And this makes sure we get a random number that's not bigger than our array. So our array has 26 items. We don't want 52 to come up. We want it to be a random number between 0 and 26. So now we have a random index.
Why, between 0
Half of that.
So yeah, so we're looping through this, and each time we're removing a card. So if we generate a random number that's between 1 and 52 each time, at some point we might run into an issue where our random number is bigger than the actual length of our deck because we're removing a card from our deck each time. Does that make sense?
So do you do this twice and then create a deck for one player?
Yeah. So every time this gets called, it goes through my deck of cards here and pulls out 26, or you can pass in a certain length, but I didn't end up using that. Yeah.
So, in this example, you're always pulling from somewhere in the deck that's not the top of the deck.
Yeah, some random
Is that
position
right?
in the deck.
It took 14,000 tries to get these things to work. It's like War does not, and when you're playing someone, does not take 14,000 some tries.
Yeah, that's
Because if you like use
that logic. So that's the gameplay logic, right? Like you and I are playing. We each have 26 cards, random
Yeah.
cards at this point. I put one down, you put one down. Oh, I win. I put one down.
Yeah,
you
but
put
if
one
you-
down. Oh, you win.
if you start to put, if you just only draw from the top, you start to get these repeatable patterns, and so that you almost always will. Someone will start having a lot of aces and kings and
Yeah.
things, and then you'll start taking almost all the hands.
Yeah, so that might be a benefit to what Fadon did. Our
That's what
random
I was. That's what I was attempting to do because I never played War where you randomly pick cards.
So if we randomly take cards from the deck and then get through after like the 26th rounds, we're going to start running into the same pattern, right? Like we're going to be playing more or less the same cards over and over again in like a functionally like a loop. Because I won, so now those two cards are at the bottom of my deck, and once we get past the 26th card, like I'm playing the same card that I played the first time. Yeah, that's a great point.
So in this,
That's related to the gameplay, which we're not quite at yet.
in this example though, like your 26 cards are not, it's not zero sum. Like if I have cards and you have cards, I'm not only choosing from the cards on my pile. I'm choosing from a always random 26 cards.
So
We're saying is why it would take so long.
this method, so what we want at the end of the day is for each player to have 26 cards that are random, in a random order, and no duplicates between the two cards.
Right.
One way to do that is to take our array, this cards, and shuffle it so that each card is in a random order. The other way to do that is to go through our array and pick random cards out, or pick cards out at random. That's what I'm doing. One of the side effects of doing that, potentially, is that as we're going through, actually, I think it might happen no matter which way you use. But what Matt is talking about is if we play a round, I put down a 4 and you put down a 7, you've won. So now that 7 and that 4 go to the bottom of your deck. So at the 27th round, you're going to play a 7. Because that's what was at the bottom of your deck. At no point do we reshuffle the deck. So we run into like a pretty predictable pattern where like you're going to play a 7, you've got the 4 right after that you're going to play. So we run into the issue of potentially getting in some what is effectively a loop because we're playing the same cards over and over again. But that is related to the gameplay, which we're not quite at yet. What we're doing here is generating random index and plucking a random card out of our deck to then assign to a user's hand. Okay, so here I have a random index. What I want to do next is get a card at that random index. So it's something like var card is going to be equal to this dot cards random index, right? This is going to get me whatever card is at this index, and because this index is random, it'll be a random card. But it'll be here, and I'll have saved it in this card variable, and I can push that into my hand to return that I'll eventually give to the player. But that card is still in my deck, effectively, because I haven't removed it. So if it's a Queen of Hearts, I will have now in my hand the Queen of Hearts, but there's also a Queen of Hearts in the deck. So the next time I call this, player 2 could potentially also get a Queen of Hearts, which is not good. So what we want to do is remove it from that array, which we can do with this splice method. If I do this, then card is going to be equal to that card, whatever random card I pull. What I can then do is something like this dot cards dot splice random index 1, and that will remove the card at that random index from the deck of cards. And then after that, push that card into the hand. And now, because I've removed that card with splice, the next player can't also get a Queen of Hearts. These 4 lines are doing effectively the same thing that my 2 lines or so was doing before. Yeah. Yeah.
So we were talking about splice in this case, and I actually use splice, but I'm wondering what's the alternative to using splice? You said there was like another method to remove that cards.
There's another method called slice, and I'm not sure exactly what the difference is now that you put me on the spot about it. That's one that you might be able to use. There are methods for removing cards from the front and end of an array if you've randomized your array. So if you've done what FitOn has done, then you can just, well, you can also splice, right, from 0 to 26, 27, and then you'll have 26 cards, right? 0 to 25, there we go.
I think slice just keeps the in your
It
deck.
keeps it in your deck, but it returns it.
Yeah.
So it's kind of like doing this, so because it would still be in the stock cards.
Yeah, because I remember looking into it, but it didn't work. I think that was the reason.
That makes sense. Yeah. You don't have to use this splice. There, with anything, any like programming task, there are a million ways to do it, and no one that necessarily is right. So, yeah.
And did we remove that? How come we don't have the array index 0 in this case?
Because in this case, I'm not capturing, slice is a function, right? And with functions, we can return values. Splice returns whatever items we remove, and it returns them as an array. So if I do random index here, 10, I'll remove 10 cards, and then this splice, or cards.slice, would return an array of those 10 cards, which I could use if I wanted to, with something like var removed cards equals the splice, just like that.
And the way that we're putting that in there with random index 1, that's something special to splice, saying that, like, right?
Yeah, so splice is a function. So at some point we have, somewhere in the deep, dark back corridors of JavaScript, there's something like this. Array, function, array, this dot splice equals function, array, index, and then some code, And this sum code is going to take care of removing this number of items from this array. And then return removed items. Something like that. So this splice is just a function. So those are the parameters to that function. Cool. Okay. Those are all really great questions. Thank you, guys. So are there any more about the deck before I move on to the player? All right. So the next class that I had was a player class. This player class was going to represent my 2 players in the game. So I have a username, right? The instructions said that we needed a username. So this is our username. Each player is going to have a hand. I'm going to deal each player 26 cards, and I'm going to store that in this hand array. And then I created a bunch of other like helper functions to help kind of clean up my game logic. So I'll get to those in just a sec. The other one we want to talk about is draw cards and current cards. Okay. So we've got a username, we've got a hand. At the beginning of the game, that's going to be 26 cards. And then I've got this.current cards. This.current cards is where I'm going to store every card that the player draws. So each round, at the very beginning of the round, each player is going to draw the top card from their deck, right? I'm going to store that in this.cards. I'm using an array for 2 reasons. One, because it makes this draw cards, the function that takes care of pulling an item from hand and putting it in cards, nice and simple. The other is that my game logic is going to happen in a loop. So if we tie, if we both draw queens, then the logic is such that the game is already going to go around again, right? So if this is an array, then what I can do is when we draw, push that card into the array, we tie, so we'll go around again. And at the start of the loop, we're going to draw cards again. So we'll push cards at the end of this array. And then we'll compare whatever the last item in the array is, and then effectively, this is going to take care of the war condition before us, however many times that happens, as long as we're comparing the last item in this array. There's only one card, then the last item in the array also happens to be the only item in the array. So we'll compare the only card that we've drawn. That's probably what's going to happen 90% of the rounds. But in the case where we do tie, I'll just push another card into the end of the array, effectively, when I go back around in my loop. Yeah.
Don't you need 3 cards? Not I, D, player, and then you pull 4 cards, and then 4th card is board, and that's the one you show when you play against each other?
I think in like the real like street kindergarten rules, that's how you're supposed to play.
That's how I built it.
Okay, well that's great. That's not I didn't like require that in the description that I gave of the game, but that's great if that's what you did.
Yeah, I saw board, and I was like, okay, I know how to play it. Sorry.
Yeah.
1, 2, 3, 4.
Yeah.
Which
So
one?
yours is the pro version. When we package all this up and sell it to the client, yours is the pro, the premium version. Mine's only the free version.
That sounds
Yeah. But this would work with that solution too. I would just run this draw 3 cards function 3 times for each player, and then I'd have the card that we played. First card in this array would be the card that we played that tied, and then I'd have 3 more cards, and then I'd have another card that we would then play that would then determine whether we tied again or if one of us won. Cool. How did other people handle this? Did people use a player class? You didn't necessarily need to.
I didn't get that far. I just made player one. I just made player one.
Yeah, like objects for them.
No, I didn't even get that far. I was just like 2 minutes. But I had they had their actually I just made the array. That's it. That's as far as I got.
Oh, it's not here.
Yeah.
Right. That's cool.
I did have a player class, and I don't know if this is kosher. I think maybe that's why I'm not doing it. When the player puts on the card, the player also card had a player property, like only
Oh,
property.
interesting.
So like the cards didn't belong to anyone. It's only when they put down that it belongs to them. Like how I kept track of.
Yeah, that's really cool.
That's okay. If you can, like,
Totally totally kosher, as they say. Kosher code. Yeah, so that's a really cool solution. Rather than have a really robust player class that keeps track of what cards each player has and then functionality for drawing all those cards, etc., the card is owned by a player, right? So there's a property on the card that says which player it belongs to. That's really cool.
But if you like later on you change that property card, that doesn't affect the player. Doesn't.
No, it wouldn't affect the player. That would be a great way if you wanted to add like tracking over how many times cards got flipped back and forth. Like you could build that out pretty easily. Or if you wanted to see who started with the card and like who ended up with that card, etc., that would be a good way to do that. Cool. Okay, so we can talk about the game logic next. All this other stuff I did down here, these other properties that I wrote, or methods that I built out, are just like helper ways of dealing with this player, and they make the game logic a little bit more readable. So what I can do is, if I'm comparing to see who won, I can call the show card score method. So player1.showCardScore greater than player2.showCardScore. And what I'll get are those two numbers. It was that or something like player1.current cards player1.current cards.length -1 greater than player2.current yada yada, on and on.
Why the -1?
So this is going to give me the length. The length is going to be 1 larger than the last index because indexes are 0 indexed.
Okay, so that's
So that's why.
relating to an index.
Player1.currentRcards.length would be undefined because this would be 26, and the index for the very last card in my array is 25 or something like that. All right. So that's what all these do. Show current card, show hand length. These I use when I print each round of the console. I show how many cards each player has. I show which card each player drew, so I've got a method that helps me with that. And then I've got this one here called collect winnings. So if I win, or player 1 wins, I can call this player1.collect winnings and pass in player 2, and then take the current hand and add the cards that I've drawn and the cards that they've drawn. I'm using the concat method, which is going to generate another array based on these 3 arrays. And then I'm overwriting what's currently in this dot hand with that 3rd array. Man, that's a lot.
Wait, so the last part, you're replacing something with this, that.
Yeah, so we have to like deconstruct this line in terms of like the order in which JavaScript does all this stuff. So I'm going to take this dot hand, which is my current hand. It does not contain the card that I drew and the card that I just won. Those are stored in my current cards array and in player 2's current cards array. So I'm going to take this dot hand, call the concat function, which is going to take this dot hand and then whatever arrays we pass it and concat. So add them all together, and then return another array based off of all of those. So based off this dot hand plus this dot current hands, so player 1 dot hands, player 1 dot current hands, and then player 2 dot current cards. So this is going to evaluate to one array that is going to be the combination of every card that I have not drawn yet, the card or cards that I did draw, and then the card or cards that the other player drew. And combine all those into one array. And then I want to assign all of those to this dot hand so that this dot hand, so my player's hand, now reflects that I've taken those cards. Yeah?
This dot hand, Can you scroll to the top because I forgot like how this got in?
Do one better.
Okay, I understand. How do you use this? I can see the function, but then you're nested inside.
Yeah, I'm inside my player class.
Yeah. So the scope is.
Yeah. So then the important next step in that is this .current cards, so player one .current cards, still has cards in it. So if I leave it, the next round, I'll push those cards in plus whatever other cards I want. Or if it's player two, whatever cards that they've won. So the first time, let's say I'll push in one card, then this .current card still has that card in it. So the next round, I'll push in that card again plus whatever card I just won. And then the next round, I'll push in that first card plus the second card, and then now the third card. This is assuming I actually win this much, which is not likely the case. So this .hand is going to start to equal a lot and a lot of cards. So I just assigned an empty array over like my current cards as well as the other players' current cards. Okay, any questions about that? No. Okay. Did people do something totally different? Yeah? What did you do?
So I had like my step 3 was comparing the players' hands. And at this point they each had like 28.
Yeah.
And on each iteration, it would be allowed to compare that, whichever one was greater, I would take the weaker hand and push it into the stronger hand.
Yeah.
So I had that going, but then I got stuck at like, how do I know when to stop? So
Oh,
what's
right.
my iterating condition? Because if I'm just saying, do this until somebody has
Yeah.
0, then that somebody is going to be changing variable.
Oh, interesting. I
And
see. Yeah,
that logic got lost.
interesting.
I
Okay.
kept having like either infinite loops or just said, oh, break at a certain point. So I tested by like setting like do this 5 times until if we have one, it will not be counts.
Yeah.
And
That's
that
cool.
way, could you do it until the length of whatever the player's hand is 0?
Yeah, under the way that I did it, that's how I did it. So I set a variable called no one has won yet to true, and then based a while loop off of that variable. And then down at the very bottom of my while loop, all the way down here, scroll, here we go, all the way down here, I check to see if does first player have no more cards left? If so, second player won, and no one has won yet is now equal to false because player 2 is 1. Otherwise, is second player's hand empty equal to 0? If so, then the first player has won, and now no one has won yet is equal to false because somebody just won. Yeah. Yeah, you were very
Very
close.
similar to that, but it was in a weird.
Oh, well, you're very close. You'll be able to finish it up. Maybe during the break or something. But that does bring us to the gameplay. So I abstracted out gameplay into this game class, which I really just did for funsies. Not at all required, but just for fun. It lets me do something like new game, pass in 2 players, and then call game.play. And then the game plays with those 2 players that I passed in. And then all this code here follows along with the game logic. Yeah.
My question is, how would you do this with more than 2 players? Like one thing I did was try to, when I wrote it, I was thinking about, all right, I've played more family, all right, that's like 4 or 5 players, all right, make sure you can divide by number of people. So I have number of people as a variable, which I accepted the most. They didn't assign anything to it, but the idea is that with this, how would you allow that number to be expandable?
So you can still do something like this and just pass in all those players here. And then here, instead of first player, second player, there's I forget the exact syntax, but there's a way of doing like an unknown number of arguments.
Okay.
And so you get whatever the arguments are as an array, and however many there are, whether it's 2 or 100, then you get that array, and each one of those is presumably an instance of your player class. That's one way to do it. That's really cool though.
What is a smart way of, like, my actions depending on who won would be the same, just switched? Like I'm doing, like as a dealer, for example.
Oh, yeah,
I'm doing
yeah.
the same thing with the first player or the second player, depending on who won. I wasn't sure how to do this, so I just like wrote it out, but they were exactly the same thing, just first player and second player switched.
So kind of like, so this, sort of replacing this logic with something a little more succinct. This is checking like, did they tie? Okay, they tied. Did one player win? Okay, first player won.
Right.
Did the second player won?
This is pretty succinct, but I was just like constantly lines and lines
Yeah.
of stuff that were exactly the same.
I don't know. That's a good question, actually. I don't really have. Sorry.
Like the line, the group same basically, and like conceptually, like I look at first player's card, second player's card,
Yeah.
that score maybe, and then go up to the parent and then be able to like grab that. But
That's a
I
good
wasn't
question.
sure.
I don't know. There definitely are ways to clean this up. One thing you could do is put your players in an array, in an array called players, and then loop through your players. I don't know. I'll have to think about that. That's a really, really good question. Okay. Do you guys want me to go through the game logic? Or we can take a break and then move on to the class. Yes. I hope it still works. I actually don't know.
You said you recorded your screen during all of these things.
Yeah, and I will give you the link to that.
You're narrating or
I am narrating it.
Are you really?
Yes. Hopefully it doesn't put you to sleep. I don't know. My voice gets a little bit monotonous. It was late. Yeah. I did it through once, and then the like audio kind of cut out halfway through. So I was like, oh, I gotta do it all over again. So I did it all over again, and then my dog started barking and wouldn't stop barking. So I had to put my dog in her crate and like be really quiet and pretend to not be home so that she would leave me alone and stop barking. And then I did it a third time, and I think you can still kind of hear her barking once or twice in the background. Towards the very end, my fiance comes home and like opens the door super loud and was like, "Hey Zach, how's it going?" But I was like, "All right, that's it, we're done." So I don't know why I told you all that, but
so yes.
yes, the answer to your question is yes. Okay. Cannot read title of undefined.
Just make changes.
We did make changes. I wonder if that's why. Well, I hope that's why. Cannot read red line. What's red line? You cannot read title of undefined. So it's in player. Well, now we can cover going over error messages.
Yes.
So cannot read property title of undefined. That means at some point we're trying to call title on some object that isn't actually an object, or we're expecting something to be an object with a property called title, and it doesn't happen. Here we can say it's at player.showCurrentCardTitle in player.js, line 35, column 23. Ooh. Yeah, the column, so if I do a space, that's one column. If I do another space, that's two columns. If I do an A, that's a third column. If I do B, C, D, E, F, that's maybe like 6 or 7 columns at that point. So player, line 35, this dot current card dot title. So this dot show current card. Oh, I actually don't know why I did that.
You moved one of the functions.
I did. Did I move show current card? No. Show current card is right there.
So
It's
show current card title. I'm 33.
yeah. We took out this function.
Took out
This function.
title.
Yeah, the
So
function-
if I console.log current card, this should be equal to a card that is in my show current card, in my current cards array. So this right here.
Yeah, the collect winnings function is the one that doesn't have
The
property called ten.
Oh, yeah.
So that's part of the card, right? This card title class.
The slice.
Oh yeah, actually, could be here.
Yeah,
Something having to do with this. This is where we change the modes.
yeah.
So let's console log our card right before things break, and in theory this should be equal to undefined. So we should, if we come here, Control L, there we go. So node index that. Yeah, we got undefined. So now that's right here. So we can go up to this method here, and instead of doing this, let's do var card is equal to all of this, and we'll return card. But before we do that, let's console.log card, and hopefully this doesn't take forever. So still undefined there. Huh. Why did this break? Speechy. There we go. So what I did is we made a bunch of changes. Luckily, this is a repository, and we're using Git to track all of those changes. And I had committed back when it still worked. So I had, if I had run git status beforehand, I would have had whatever files I changes and whatever those changes were. I ran a command called git stash. And what that does is take all of those changes and stashes them somewhere. So I can do git stash pop, I think. Yeah. And here we go. Here are our changes again. And so if I run node index, it breaks again. But I can also just restash those. Whoops. Git stash, there we go. And then run node index.js, and ta-da, somebody wins.
When you're in the terminal and you are like typing index, but you don't actually type out all the letters in index, how are you?
Yes.
Why does second player like win so evenly?
Better.
It's just better at war.
Yeah, Tim is significantly better at war.
I guess after a certain point, the probability of winning versus an
Yeah, it kind of like tips its scale. I don't really want to like scroll back through all this and figure out what happened. If you want to investigate, you're more than welcome to. But like you can see here, I was like doing all right, and oh no, never mind, I wasn't. It looked like, I mean, I had like no hope. But so here I had 9, and then I 8, and then I started to win a few, kind of like I'm going back up, and then I just kind of like tanked, and then that was it. So like, I don't know. I haven't been following along with March Madness enough to make a March Madness joke, but like I probably tanked like Duke tanked or something. Maybe. I don't know. Did Duke tank? Yes? Yes! Oh man, not because I don't like Duke, but because my joke worked.
Sorry. More like everyone's brackets.
Oh really? That destroyed everyone's brackets? Yeah, that makes sense. Everyone's like, Duke, you know, they're probably gonna make it to the Final Four, whatever. Anyway. Somebody had a question that I was answering when we did this, and now I've totally forgotten it. Tab completion. Yes, thank you, Tim. So if I do node and then ind and hit tab, it'll just complete the rest of the file name. You can do that with folders and files. You can do that with like paths. So if I cd up, whoops, I ran the file. So cd, I think I have it dev, ga. And then if I cd into 04, 07, there we are in the class for today. So that's a great question.
Is there multiple things that match the letters that you typed that won't do it, but you keep messing tab, it'll give you a list of all the things that it could be?
So if I go into dev and then type GA, I have a folder called GA for all the work that I do for GA. And then I have another one called games for all the video games that I make. And GA obviously matches with both, so it's like, hey, which one do you want? So then I can type a slash and then keep going with like 4, test class, 7, exercises, whatever. Yeah.
So, you pull upstream master didn't work for me, I think because I haven't set up the upstream or something
Get
like that.
pull
So I
upstream
tried to pull it again, but what is in a separate repository, so do I need to do npm install in the repository?
That's a great question to ask on the break that we're about to go on. Okay. Yes.
What's that change usually?
So it's going to be the URL is live for most things. There's one here, there's one there, there's a couple there, there's a couple there, there's a there,
I'm pretty sure.
I run a game and I had to sit down the next card when I eventually crash. And I actually I didn't know which all was not there. So I know what's happening.
It's just
Already good.
Pretty much like where I thought would be. So. I was like, I'm watching along the way. So I got man, I was like, what's okay. Yeah, I just I didn't do. You know what? I gotta go 2 hours. Yeah.
Spice, starting that already, it's like an hour and a half. I'll be here. But it's better than. His access is I was trying to use blocking items. I think it works, but I have a problem since that. If you use splices, it returns the item. It takes it out of there, right?
Yep.
I was just like pushing that into what one there. I was pushing that into the other person's head.
The whole array.
No, whatever it returns the one, like I was comparing this one's bigger, slice it, push it into the person.
Oh, okay. Yeah, you can do all that in the game logic. You don't necessarily need to like abstract that out. The only reason I did was so that the game logic looks a little cleaner.
It definitely looks ugly.
Yeah, and it like kind of cuts down on the duplication, right? Because I have a function, so I just call that function rather than write. Remember all those steps, etc. Let me grab something to eat, and then yes.
Yeah, so like I said,
I didn't like this.
I did that. I like to speak slow.
Here's a well, it's passing the time there.
That's where
And see, yeah, like it's clear and then chance yeah, I guess they my condition should be.
So I would say a while is probably your best bet. Doing something really good. So wow. You could use a variable like I did. Or you could do while layer one dot stand up script that's able to be accurate to make yeah, the problem with the for loop is you need some sort of fixed length to run loop again. But we don't know how long.
I did switch it at some point and then maybe it was it just was way forever. and must be wrong. When I switched to values, I'm like, this is.
Yeah, make sure that whatever your while loop condition is based on, at some point you can break that so that your while loop breaks.
Yeah. Well, I had it iterating in the end, like while I was trying to figure I felt like I did the great combinations like why this is.
You don't necessarily need you just need something that is true. Which I can plug to this. It's really fascinating. You can, the code, my solution is pushed, you can read through that extensively. Full check
Question,
it's like very one, very
Yeah.
I think some languages, if you do a small meta programming to do for the regular designing codes, it is do that with JavaScript. You can't do it here.
Okay.
But we can do it, you can have proper decision on it, or
Yeah.
effectively.
Yeah. It's like when you see this review, for example, like,
Yeah.
yeah, now you put the variable name in the, you put the build variable name.
Yeah.
But I just thought.
Yeah, just loop through those variables. Compare the score. Let's do it at the beginning of class. You turn it now and then sign to.
Oh, I thought it was just
Super. Yeah, I'm Tim, by the way. I'm your substitute TA for the evening. That's my bad. I should have introduced Tim at the beginning of class. Tim is filling in for Christine. Christine tripped and fell and landed right on her face, and then her whole head exploded.
okay, no,
None of that happened. None of that happened.
I
thought it was just too friendly. Surprise! No. Christina's fine. She's at a national park on holiday. I forget which one, but it was really, really cool. She's there for the week, and then this weekend or at the end of the week, she's at a bachelorette party or something like that. Not at the national park, whatever. But yeah, she described her vacation to me, and I should remember it, but it sounded super cool. So. For some context, I actually used to work at GA. Like you met Lauren on the first day of class, right? I was a Lauren at GA, and then I took the full-time web development program, and now I'm a developer at Social Tables. So if you have any questions about like the full-time program, I also took JavaScript and took front-end web development. I've taken a lot of classes at GA. I've been through GA in many different aspects. If you have any questions about like what you're working on now, or just being a developer, I guess I know about that now. Tim's your guy. Okay. So let's see. We are done here. So if you haven't already, go to your class repository and run git pull. Oh, what is it? Oh, I forgot. Oh no! Oh no! I never remember it. What's it called?
Git pull upstream master.
Yeah, git pull upstream master. I'm bringing the candy back, so I'm gonna start throwing candy at you guys again. Mike, do you want a piece of candy? Ready for it? Perfect. All right. Git pull upstream master. That's gonna get all of the changes for the class, in particular the ones for today's lesson. All right. Everybody got all their changes? Everybody's running Git pull upstream master? We're off to the races, the coding races. I'm going to assume that your silence means yes.
Yes.
Okay, cool. Cool. So first off, before we talk about the class, congratulations, everybody. We've finished the first third of this class. This class is divided into 3 thirds. That's what thirds were. Divided into 3 thirds, and we finished the first one. So congrats. All right. Well, I'll try to be congratulatory next time. Yeah. High fives. So now starts the second third. The 2/3. Today's class is going to look more like this, more or less like this. We did the review already. For the rest of the class, we're going to talk about JavaScript in the browser. We're going to talk about something called the document object model, which I'll introduce, and then working with the document object model and writing JavaScript for making dynamic HTML pages. We're going to talk about the lab. So here we go. Phase 2 of Introduction to JavaScript. All right. Now, this is our updated version of our looking ahead table. We've finished learning JavaScript, like the language features and the syntax and stuff like that, right? We learned data types, we learned objects, we learned functions. We finished learning all of that stuff. Now we're gonna keep reiterating on that, right? Like we'll keep learning about objects and functions and things like that, but we're gonna learn how to use the language to actually start building applications. And that's what this section of the class is really gonna focus on. It's the meatiest section of the class in terms of content or material. I think it's also going to have the most value, right? At the end of this, we're going to be able to build dynamic web applications that work with databases, that have users and things like that. Yeah. So this next section of the class is structured in such a way that we're going to start at what's called the front end, or the client side of an application. And what that means simply is the HTML that your users are going to interact with. That's what we're going to learn today when we talk about JavaScript in the browser and working with DOM. After that, we're going to talk about responding to user input. So when they submit a form, or when they click on a button, or something like that. When our users interact with our application, that gives us new data that we then need to work with. We do that with events. Once we've talked about events, we'll talk about something called templating, which is a way of dynamically building HTML pages, either on the server or on the client. We'll talk about it on the client when we do it here. But what this means is we can take, let's say, a to-do list application. And when a user inputs a new to-do, re-render that to-do list application, the HTML for that to-do list, using templates. One template for an item in our to-do list, one template for the whole list itself. We'll re-render all that using templating. And as part of that, we're going to talk about something which we call build tools, which are tools written in JavaScript that let us automate mundane tasks. For templating, we can use this to render our templates based on data. We can also use this to minify our JavaScript. So we're going to have a JavaScript file that's going to have all of our application logic in it. We're going to want to send that to our users so that our application actually works when they visit it. But it's going to be a big file. Using build tools, there we go, we can make that file a little smaller and a little more performant. Then we're going to make a big jump, and we're going to build a server using a framework called Express. When we do that, we're going to talk about HTTP and responding to HTTP methods. So when a user visits our page, our server is going to respond, and it's going to build an HTML page, it's going to work on some data or something like that, and send some data back to our users. Once we know how to build servers, we can start interacting with databases. So saving data in a way that's persistent. So if I come and add things to my to-do list, the next time I come and visit my to-do list, they're still there. I don't have to rewrite my to-do list every time. Once we know how to build servers and work with databases, we know how to build APIs. Because in many ways, all an API really is a way for us to interact with a database through a server with routes, which we'll talk about. Probably when we talk about APIs. So we'll talk about building our own APIs, and we'll talk about using APIs that other people have built to get data that's stored behind you. We're going to close this section off with a lesson on how to architect our applications, where to put what code. We're going to be writing a lot of different kinds of code, logic, business logic, rendering logic, stuff like that. And we'll talk about where best to put it in this class. And then we'll do our second lab. For our second lab, we're going to build out a clone of the popular Hacker News website that's going to let users submit articles, vote on those articles, and comment on those articles, just like on Hacker News. Okay. And then right around here, probably class 11 or 12, we're going to start thinking about the final project. We'll have a couple of exercises that will help you with ideation, coming up with an idea for your final project. It's still not going to be due for another like 3 or 4 weeks or so at that point. But we'll get started thinking about it here. All right. Okay, who knows what a browser is? All right. Okay, so that's a silly question. We're not actually going to start with that question. If we remember back to the very, very first day of class, I drew that big timeline that stretched the whole length of the board. And over here, at the very beginning of that timeline, we talked about how JavaScript was initially designed as a scripting language for web pages. So we send the user a static HTML page. Within that static HTML page is a link to a JavaScript file that the browser then goes and gets. That HTML page is static, meaning nothing's going to change. It's not going to respond to any input from the user unless it gets that JavaScript file. That JavaScript, or as JavaScript was initially designed, it's going to let us respond to the user. So when they click on something, we can animate something from one position to another, or we can submit some data or go get some new data, anything like that. This is originally what JavaScript was designed for. And this was originally all it was designed to do. It wasn't until, if that was the start of my timeline, this was the end, it wasn't until around here that we started getting server-side JavaScript in Node.js, which is the JavaScript that we've been running, right? Okay. So this is largely still what JavaScript is used for today, for working on the front end. More and more, we're seeing it on the back end, on the server. But by and large, this is what it was initially designed for. This is what it's really good at. And this is what we're going to learn today. Okay. So a user is going to visit your page, or the front page of your application. And a bunch of things are going to happen. First off, the user is going to type in the URL, right, like LevansBillionDollarIdea.com. Enter. Right? And the browser is going to go and get an HTML document. And it's going to parse that HTML document. It's going to look for other things it has to go get before it can actually render something, like CSS and JavaScript. So it's going to go get those files, images too. It's going to go get images. And then it's going to use the browser's rendering engine to actually paint the web page on your screen. When it does this, it's also going to build in memory a model of the data in your document. We've talked a little bit about models, right? When we talked about objects and object-oriented programming. That model, excuse me, is called the document object model. Super creative name. The document object model is an object model for the document that we're rendering on the screen. And that's it. But it's an object. Wait, we've never worked with objects before. We have? No, I don't think we have. I think that's in your other part-time class. Right, we have talked about objects. The DOM, as this is called, the document object model, is an object. The browser builds for us when it builds a web page, builds and renders a web page. And it's just a plain JavaScript object. It has properties and it has methods. And those methods, we're going to learn a bunch of them today. Those let us work with the data that's stored in the DOM, or the properties. All right, so let's see it in action. I'm going to open up Chrome, which I actually already have open. So maybe Captain Obvious to walk out of that Hotels.com commercial or something here. So actually, what I want to do is open the inspector. And there's two ways to do this. One is on a Mac, Command-Option-J. Yeah, Command-Option-J, and that will pop this open here. The other is to right-click and view inspect. That will open up the HTML here under Elements. So then I'm just going to click on Console right here, because this is what we want. This is Console. And let's see if I can make this bigger. Yes. Actually, what we're going to do is this, and lost it. So here, do that, and boom. That's a little too big. There we go. So this is my console. Now we know everything in JavaScript is super confusing. So this document object model, wherever it is in this browser, it's going to be someplace super weird. It's going to be really hard to remember. We're going to have to take notes to remember it. It's stored in a variable called document. That's not so bad. What we're looking at here is an interactive JavaScript runtime. Not very different from when we were in the terminal and we typed node and hit enter, and then we could type JavaScript. You guys remember that? This is very, very similar. Many of the methods are the same. Like console.log. Console.log document. You can do this weird undefined, representing my return value. All of y'all thought that was going away. You were wrong. So the document. Let's explore this document for a little bit. If I click on it, what do we think that is? Yeah, that's the HTML for our web page. Is that what everybody expected? Kinda, maybe. If not, that's okay. That's not what you were expecting.
Like the tree or
Yeah, maybe be like an object tree.
yeah.
Yeah. So let's try this. Oh. So this console object that we've used only the log method on so far, and the browser has a couple of other methods, including console.dir. And this is going to print this out as an object using the object syntax that we're probably more familiar with. So here we've got our, our key and our values for all our properties. We've got a couple of other properties in here, like, ooh, look at all that. This is the document object model. Well, this is our way of accessing the document, is through this document object. There's another one. There's another object that the browser builds for us, just like the document, and it's called window. What do we think window refers to? Sorry? Yeah. Oops. So that's an object that represents the page. These are all the methods and properties that it has.
What's the difference between window and document?
The document is an object that represents our actual page here and the data that's stored in the HTML. The window is an object that the browser is going to build for us, kind of above that. Sorry?
I think you said the browser also builds that.
Yeah, it builds both.
It's a parent, Windows is a parent of document.
Not really a parent in that they're not too related. The document is in reference to the HTML page, whereas the window is in reference to the browser.
So mostly we'll care about the document.
Yeah, we'll mostly care about the document. And all of the methods and stuff we're going to learn today are on the document object. All right. So let's see here. Cool. Has everybody played around with the console a little bit? Good. That's where, when we start building applications, that's where you'll debug them. You'll run console.log in your JavaScript file, and it'll output it there, and then you can play around with that data. Let's talk for a minute about getting data into a getting JavaScript into an HTML file. So if I come to the exercises folder, let's see if I've done this already. Hopefully not. I have this one.html file. I can go ahead and open by going back to the terminal and let's see, the exercises, open one index.html. The command line, if I run open one index.html to that HTML file, it'll open it up in Chrome. Open it up over here. There we go. How do you open in Chrome? Sorry. Open in the path to the file. Yeah.
That just goes to the default browser?
Yeah, so for me that's Chrome. It could be Safari for you, it could be Internet Explorer, what have you. So what I want is to get HTML into this page. It's going to run on this page. There are two ways for me to do that. One is inline. So if I go to the actual HTML page, there was this on line 24, this script. I've gone ahead and deleted that right now. I can inline JavaScript with the script tag. And then console.log, hello. If I go back to the browser, and refresh the page, I get hello printed to the console. Going back to the HTML. This is all I've done. How many of you guys have done something like this before? Maybe a few? Yeah. Yeah. So then we're off to the races. We can just write our whole application right here in this HTML file. Right? Yeah, does that sound like a good idea? We can.
Short enough.
Yeah, if our application is short enough, we can do that. But for most of our applications, we're probably not going to want to do that. We're going to want to include an external file where we're going to write our JavaScript. We do that with scripts by adding a source. This source is going to be the path to our JavaScript file, which if I look at my tree here on the left, is at the same level as my index.html file. So I can just include it with something like index.js. And to see it working, I'm going to go to that file and I'm going to console.log. Hello, world. Just like that. Go back to the browser, refresh, and we get hello world.
How do you open the HTML file in Sublime?
In Sublime, you have to do some extra stuff to add a Sublime command to the command line. But there's a script that you can run that will make it so you can just do something like Sublime and then a folder, and it'll open the whole folder in Sublime. Otherwise, you can open the directory, so open the period, and then drag and drop the directory onto the Sublime icon in your dock. Or right-click on the file and say open with Sublime. Yeah. So including an external file, very simple. My script tag, I give it a source. The browser is going to parse this HTML page, see that I'm getting an external file. It's going to go get that file, and then it's going to execute it. Cool. All right. We're going to do this like 99.9999, a lot of nines, % of the time. Because this is going to let us write a lot more JavaScript more easily. Okay. Any questions on that? No? All right. Now we can talk about this DOM thing and what it is, why we need it, what it's useful for. So the browser is going to build the DOM for us in that document object as a way for us to interact with the HTML more easily. When we're in the browser, it's a native part of JavaScript, browser-based JavaScript. It does not exist in Node. But just like module.exports is a native part of Node. In the browser, we have this document object. It has a bunch of methods in this object that we're going to use, we're going to learn in a few minutes, for accessing parts of the page. Thinking back to whenever it was that you learned HTML, what are some ways of identifying an HTML element?
Classes.
Yeah, classes. So there's a JavaScript method, a document method for getting an element by its class name, or getting multiple elements by their class name. What's another way? ID, yeah. So there's a couple for getting items by their ID. Any others? Yeah, tag name. So we can do that as well. Are there any others? Sorry? Selectors. So class and ID, those are all selectors, CSS selectors. You can do data attributes. That's not as common, but using the HTML data attribute, you can select an element. If you don't know what that is, don't worry about it. We're not really going to talk about it. But yeah, these properties or these methods let us access parts of the document. When the browser builds the DOM, it's going to build it in a tree structure. We've talked about trees in terms of the file system, right? In terms of the file system, when we say a tree, what is it that you guys think of?
Outline.
Yeah, kind of like an outline, right? Can you expand on that a little bit?
So you have, for example, in an outline, you have Roman numeral 1, that's like the top, the parent of the root of your tree. And got all these ABCDs, the next level, and then inside you nested lists underneath that, or you can think of it as nested lists.
Yeah, that's absolutely right. There we go. So we're going to have our sort of root item, right? Which will maybe be like Roman numeral 1. And then we'll have our other items below that. And then maybe sub-items below those. And those can have sub-items. Like that. This is an outline. If we think of the file system, when we talked about trees, it's not too different. Actually, let me do them side by side. So here we have an outline. And here we're going to have the file system, right? We've got that. What is that? I think I heard someone say it.
Root.
Yeah, root. And then maybe below that we have something like user, right? And then on my machine I have something like this. And then below that I have GA, and I have projects, etc. This is a file system tree. When we're building the DOM, what do we think the root is? Yeah, so the DOM is going to represent the data in our HTML page. So when we're building an HTML page, what's the outermost tag that we're going to use? Yeah, the HTML tag. So we'll have that. And then let's see, what else might we have in there? Yeah, head. What, somebody else said something?
Body.
Yeah, body. What might we have in the body tag?
Header 1.
Yeah, H1. P tag. P tag. And then underneath our header 1, we'll have JS is the best. Right? Or not, I don't know. Hopefully that's how you feel. Yeah. So that's what the DOM is going to do. Yeah. All right. How do we feel about all of this so far? It's been maybe like 3,000 people, right? Should we do a fist of fives? 5? Only 1 of 5? All right, good. Let's make sure I didn't miss anything. No, I did not. All right. So now we're going to start learning some of these methods for actually working with the DOM. And what these methods are going to do is go to this tree structure and look through the whole tree structure, for instance, for an H1, and then pull that H1 and say, here you go. It's going to return that H1. When we talk about working with the DOM, we mean a couple of things. We mean getting data from the DOM, right, from the HTML, like this H1. We also mean setting data in the DOM. For instance, changing the text within this H1. We're going to talk about getting data from the DOM first. There's a collection of methods specifically for doing that. This is our first set of methods for getting data from the DOM. Here's our document object, just like we saw before. And then we've got 3 methods on it. Get element by ID. What do we think that's going to do?
Find the element that has matching ID of ID. So like for example, div that has ID equals my ID.
Yeah, exactly. Just like my ID. What about get elements by tag name?
Means that they have the same tags.
Yeah. So in this case, div, the tag of div, this is going to get all the divs on the page. And what about get elements by class name?
Same class.
Yeah, it's going to do the exact same thing, but for classes. That's nice. So let's see. Okay. So if we switch back to our index.js file, index1.js file, we can see these in action. So here I've got my HTML page on the left and my JavaScript on the right. I want to get the element with the ID of the title. I can do that with document.getElementById and then pass in the name of the ID. So var title, and then let me console.log title. I'm going to come back here. I'm going to refresh it. There it is. There's my H1 with an ID of title. This is good. It just proves that we get our title back. But we assume that if it's going to be in the browser, it's going to be shipped to every browser everywhere, then it's going to do what it says it's going to do. So let's see what's actually in here, because that's probably going to be more useful for us. So I switched console.log to console.dir. So I'm going to refresh the page. There we go. And I'm still getting my title back. Yeah, absolutely. How about that? Whoop, that was not what I was trying to do. This doesn't look too different from when I console.dir the document object, right? Or does it?
It may have less stuff.
Yeah, it's not going to have as much stuff. When we print document, we're getting the whole thing. Whereas when we do this with just our H1, we're just getting our H1. But we're still getting a ton of stuff, right? Look at all this. Got this attributes array. I don't know why it jumped me down to the bottom there, but that's really weird. Oh, it's probably because I'm scrolled. We've got child nodes here, which is text, and then that text, wow, look at all that. We've got the actual data for that text.
Would you just pull it up?
Node value. Console.dir. Yeah, question? Console.dir. Yeah.
Are there any of these,
DIR, yes.
are there any of these children that we need to pay more attention to, like child nodes?
Yeah.
What is it? Data seems very interesting if you didn't want your HTML to be in your output.
That's right. We will, let's see.
Or am I jumping ahead?
I think you're jumping ahead, but
Forget my question.
I'm not totally positive. So if not, I'll come back to it. How about that? Deal.
Can you go back and walk through what you did last like 4 steps?
So I've got my HTML page. At the bottom of my HTML page, I'm importing my JavaScript file, right? In my HTML page, I have an H1 with an ID of title. Then in my JavaScript file, I'm calling this this method on the document object, document.getElementById, and passing in that ID, and then saving the return value of that to a variable called var title. And then I'm console logging, or in this case, using console.dir for that title, so that I can see what's inside of it.
Again, if you get stuck along the way, raise your hand.
Yeah. Cool. So what are some of these other methods that we talked about that we could use? Why doesn't everybody try getting that title by its tag name? So using this get elements by tag name. I'll give everybody 5 minutes or so to play around with get elements by tag name. You're trying to get the same H1 element, but instead by the tag name. And then in 5 minutes, I'll check back in, and we'll do it together. Ooh, careful. My sheet. My sheet. What about halfway through, part-time? You want to try that class?
Yeah.
This one's an easier.
Sorry. If you finish early, feel free to do class name.
Yeah.
All right. Get element by tag. Get element by tag name. So rather than var title, I'm going to do something like. There we go. So var title is equal to what? Who wants to walk me through this for a Kit Kat? For 2 Kit Kats. Very
Just document dot get elements by tag name. And then
There we go. Fun. All right. And then down here, I'm console.dearing title again. Let's just console log it. We don't need all that other stuff. And we'll come back here, we'll go back here, and then we'll refresh. Oh, wait, what happened? It does, it looks different. Huh.
Like an array.
Oh yeah, it does, doesn't it? So it's an array. This is like, I think this notation is a little bit weird, but we have one item in our array. But when I open my array, I get all this other stuff. I mean, it tells me the length here, which I guess is nice. It tells me the length here and here, but anyway, yeah, it's going to give me an array. And then, yeah, there's a ton of stuff in there, just like there was when we console.data before. Good job. 2 Kit-Kats for me. Good catches. I feel out of the habit of throwing Kit-Kats at my students. Which is maybe the best. That way nobody gets injured. Okay. Okay, let's go on to the next slide. Okay. So all of these document methods follow a formula. First off, they're all on this document object, right? When we talked about objects, we built an object, and then we put parameters and methods in that object, and when we wanted to use those, we could either use dot notation or bracket notation, right? Well, document is an object, just like we learned about. And so we can get these properties, methods, excuse me, using dot notation. Just like you did in your lab, just like we've done in previous exercises, etc. But the browser is going to build this document, and when it does, it's going to build a couple of methods for us. So using these methods requires knowing the method name, like getElement by ID, or getElements by class name. And then we're going to pass in a selector, which is how we're going to identify which element on the HTML page it is that we want. So in the first exercise, the one we did together, we used getElement by ID. And we passed in the ID of the element that we wanted. And then the one that you guys did by yourselves, we used the selector getElements by tag name, or the method, excuse me, getElements by tag name, and you passed in the selector h1. There's another way of getting data from an HTML page, and that's with using query selector. There are some differences between the two of these, which we'll talk about. But query selector is a newer part of the JavaScript language. GetElement by ID, getElements by tag name, anything that starts with either getElements or getElements is probably part of the original spec. Query selector, I think, was introduced in version 3, but I could be wrong. Maybe version 5. So, in theory, there's some cross-browser compatibility issues, but raise your hand if you're using Internet Explorer 6. Yeah, I didn't think so. So we're going to be all right. Query selector follows a very similar pattern. First off, they're all methods in our document object, right? So document.querySelector or document.querySelectorAll. And then that's the method, so those are the methods. And then we're going to pass in a selector. But we can use querySelector or querySelectorAll, whether we're selecting by ID, by class name, by tag name, by some other complicated selector. Both of these methods can handle any selector, any valid selector type that you pass in here. We're going to use the CSS syntax for selectors, right? So when you're writing CSS and you want to style an element by its ID, you use this pound sign, right? Or if you're styling based on a class, you use dot to denote that it's a class. If it's a tag, then you just got to pass in the tag. So document.querySelector and document.querySelectorAll. Let's see these in action. Are you guys ready? Yeah. Yeah, we're ready. Woo!
All right. Party.
Sadly, not really a party, but var title equals document dot query selector. What should we use? This is the element that we want. What would you guys like to use? Sorry? You want to use the p tag? Oh, you want to use this paragraph? We can do that. Bring in the paragraph, that's fine. So we're going to pass in the p tag. And then we are, oh, well, we'll save it as title and we'll console log that. That's fine. Then we'll refresh. Boom. There's our p tag.
If you have multiple tags, is it
Yeah, that's a great point. So this page has multiple paragraphs on it. It looks like we only got one. What a jit. So whether or not you're going to get more than one item or just one item is sort of like inferred or inferable from the name of the method. So document.querySelector is always going to return one item, specifically the first item that it finds. So document.querySelector is going to go through here. No, not P, not P, not P, not P. Ah, P, boom, done. And return that. QuerySelector all is going to return an array of every p tag in the document. That's more clear, I think, here, whether or not you're getting one element back or an array of elements back. But let's see, is this my next slide? No. But going back to these, it's a little bit less clear. I mean, it's still kind of clear. I don't know. Get elements by class name. What do we think that gives back? One element or an array of elements? Sorry? Yeah. Loud and proud.
Hooray!
Yeah, it's going to give us an array of elements because elements is plural. Contrast that with get element by ID, which is going to give us back an object with a bunch of nested arrays, and then inside each of those arrays, we're going to have a bunch of cards and decks. No, get element by ID is only going to give us one item back. Oh, right. There's another important difference with get element by ID or any method that starts with get element or get elements and query selector, and that's that get element by ID is a method on the document object, but only a method on the document object. Regardless of how we get an element, what we're going to get is an object back. It represents a slice of this DOM, right? Like just this p tag. Document.getElementById only works on the document, whereas query selector or query selector all works on the whole document or individual parts of the document. And I'll show you guys what I mean.
Yay.
So that yeah. So if we look at our p tag here, actually, let's look at this other p tag. And I cannot spell second. There you go. That's how you spell second. I'm going to get this second p tag by its ID. Second paragraph. There we go. If I use document dot get element by ID, I pass in the ID, and I'm going to change this to paragraph because I think that's going to make more sense. And I console log that paragraph. Oh, I get paragraph. That's what we expected. Within this paragraph, there's an anchor tag with an ID of link. If I, down here, want to get the link, so var link equals straight document dot get element by ID and pass in link, and I'll console log that. This is going to work, right? Leave out all these commas, comments, there we go. Here I'm going to the document and getting it all back. But this link is nested within this paragraph. So maybe I just want to do something like that. And to refresh. Oh, what? Type error. Oh. At least now in the browsers, our errors are this nice red color.
What are you typing in there? Console?
Oh, I'm just console.logging link.
The browser. What are you doing on that?
Oh, I'm just refreshing the page. Paragraph.getElementID is not a function. So it knows we have an object here, right? Like paragraph is an object, but this object doesn't have a method getElementById. So let's go ahead and change that to query selector. Pass in this ID. We'll go back. We'll refresh the page. Boom. There it is.
So query selector, you can use like dot paragraph or like be more specific, but
Yeah,
get element by ID, you can only do
on the document. So var
one. You can't
equals.
go down the tree.
Both of these will work, right? I have my paragraph, I can call query selector on it, or I have my document, I can call getElementById on it. But I can't call paragraph dot getElementById. This does not work. Paragraph dot getElementById.
What is the hash in your code component?
Oh, this is our selector for queries. We don't use it for getElementById, but in selectors, the hash is how you identify that this is an ID, just like when you're writing CSS. All right, let's take a 10-minute break. After that break, we're going to come back and we're going to talk about working with this data a little bit more. And then we're going to talk about setting data in the DOM. So now that we know how to get elements from the browser, we'll talk about editing those elements and then making those changes appear on the page. All right, so 10-minute break. That's enough time for at least 3 peanut butter and jelly sandwiches.
Let me review it.
Yeah.
Yeah, so it would be. Sure. Let's look at the errors. Okay, so let's look at the
that's well, in this thing there is get element by element. It's not get elements is so that's what that arrow is. But also one thing is set a title equals and then you make me two variables title and so then you're all like so exactly, yeah. So like you might be good like okay. So next we'll say paragraph 5. This is what we write. It has to do with paragraph right here. What is paragraph? Sure. Okay. Oh yeah. Well, the reason he had said he had done that one he got all he got that. The first then once you had paragraph, then you can do paragraph. Yeah, so that's what's going on there. It's saying things do that, or do that, makes sense. Yeah, you're like about it and stuff. So overwrite. This function is attached to same scope. So we call it scope.
Yeah, so but what if you use this, then it's
All outside of here.
In the like not in the classroom. Somewhere.
Yeah, somewhere.
Oh, okay, gotcha.
Last week she was in the back.
Yeah.
Like,
Oh, in the back by Rolls. Sorry.
Yeah.
There it is. Send it more space. Did you come to find it?
I sat here. I sat here. But there was nobody here because they were over there.
did you do a lab?
You know, I don't know. Yeah. That's,
Yeah.
I'm just gonna shoot, I walk in by.
I think that was an option, to be honest.
Yeah.
That's a great question.
do we have the Wednesday on the summer?
No, just to get it long.
Oh, I don't know. Yeah. I guess I'll be here. I'll be here on Wednesday. What time is Chris? Is 5 to 7? 5:30 to 7:30? 5:30 to 7:30? All right, I'll see you guys there. Clear my schedule.
Also, I would be free tomorrow, like, that would work out for you to ask for.
Okay. It's good for you to fill in. You're free?
Tomorrow, when you think?
Yeah. Okay.
Yeah, but let her know.
Yeah, I will. I didn't think about that.
Yes, you're off.
Sorry. Yeah, Skype. Hey. How's the Grand Canyon?
Super important.
Yeah, that's right.
All right.
There's always one out. All right, all right. Let's explore these objects a little bit more. So Alyssa asked me a really great question, which was, we get this object back, like, there's a lot of stuff in there. What do I actually care about? And to this, all of it, you have to memorize every single property in there and what they do. There's a test next class. None of those things are true. So I'm going to come here, I'm going to comment all this out, and I'm going to come down here and do vars. Var title equals document dot pre-selector title. Bless you. So now I have my title, and I'll check to make sure I don't still have the title there. Now I have my title. If I console.log title, I'll get the element, and if I console.dir title, I'll be able to explore that object. There are certain properties on there that I'm going to care about more than others, and we'll look at what those are. But one of them is text content. This is going to print a string of the text content of my element, just like it says. So that string is going to be intro to the DOM, and it'll be a string, just like the strings that we're already used to working with. So if I refresh this, I get the element because I console.dir it, and I can explore that. Then I get intro to the DOM, just like I said I would. And we're running type of title.textContent to check the type of that element, and we get the string back because it's a string. But while we've got it here, let's see what else is in here. So that was text content, which is all the way down here somewhere. But we'll start up here. So child element count. This is going to tell you how many child elements there are based off of HTML elements, right? So my title doesn't have any, but my paragraph with a link does, right? It's got an A tag. Child nodes. A node, whoops, I don't know why it keeps jumping down to the bottom. I only have one node, and that's text, and that's the text of my title. A node refers to each level in my tree, right? So I have an H1, that's one node, and then that has a child node, which is the string, the text itself. That's this right here. Children is useful if you've got an element with a lot of child elements. Class list. This is empty for now, but this is how we would interact with the classes, CSS classes, on this element. If you want to add one, remove one, toggle one, you can do that here. There we go. We don't have any, but that's where we could do that. Class name. This is the full string for the class of an element, if we have one, which we don't here. Client height. This is the height of the element in pixels. So 37 pixels. And then the client width. I think this stretches across the whole width of the page here. So it's 633 pixels. The data attribute API that I mentioned before, that gets stored here in this data set. So that's a more advanced HTML feature or functionality. How many people have used data attributes before? Maybe one or two. Has anybody who's taken the Feud course here? The front end course? Do they cover data attributes in the Feud course? No, I didn't think they would. A little?
Not officially.
One says they don't, one says they do. I don't know. Who can we trust?
Maybe because they went to office hours.
Oh, ow, sick burn, man. I don't know. Are you going to take that? Good. All right. Yeah. Definitely come to office hours. Otherwise, I get lonely there.
Is that client with based on like you got that window open at the end right now? So close it.
Oh, it's fine with here.
I think it is mental.
So it's not going to change in real time, like if I do this.
Right.
But if I change it and rerun it, it'll probably give me a new value.
Not you, but
Yeah, yeah.
Yeah, mine's different, so.
Client width 700. There it is.
Nice number.
All right. Yeah, nice and even. Boom. Look at that. So first element child. That's going to be the HTML element for the first child. We've got the actual ID itself. Oh, that's interesting. So we could change the ID. We could maybe dynamically use this ID to do something, right? That's not a very good. This has, let's see, if this were a link, we could overwrite like the default browser behavior for when a link is clicked, and then use the hash here on this link to find an element with that exact same ID, and then do some stuff to it, like animate it somehow. We have inner HTML and inner text. Inner HTML, here they're both the same, but as their names suggest, they're different. Inner text is going to be the compiled text of the elements, whereas inner HTML is the inner HTML of the element. So here we don't have any other HTML elements, so we don't see it. But here in this p tag, we do, right? We have this link. So if we were working with that p tag, inner HTML would be read all about the DOM and then the anchor tag, and then here. Whereas inner text would just be read all about the DOM here. See, last child, that's the opposite of the first child one that we saw before. Siblings. This sibling is P first paragraph. So that's going down the tree, right? We're already working with this element. The sibling is this paragraph, hello world. Let's see, we've got offset height. Client height and offset height are a little bit different. I always have to look up which is which. But same with offset width. We got all these methods which are equal to null. All of these are events that we can assign through the HTML. But then we're not going to do. So until next question. Sorry?
They're called action methods?
Events.
Oh, events.
So on submit, whatever. Outer text is sort of the corollary to inner text. Same with outer HTML. Inner HTML is going to be everything inside the outermost tags, whereas outer HTML is going to be including the outermost tags. So here we have the actual H1 inside outer HTML itself. Let's see, what else? A couple others. We've got the parent node. That's the next node up. But the parent element is the element up. If we had a sibling before this element, which we don't, we have a next sibling. But if we had a previous sibling, it would be here. And then the last one to play with, last one that's fun to play with is the style here. This is going to be all the CSS on this element, which we can actually interact with in JavaScript. We can change the font color, we can change the font size, we can change the height, any of that stuff through there. A lot of animation happens by manipulating the style object. Cool. All right. So that's like a whirlwind tour of this, also at a pretty high level.
For every object that you can call that way, can you also add a property?
Oh, yeah, like title. Could we add a property to title? Yeah, or a property or a method. Is that what you're asking?
It's like, can you treat it like any object in JavaScript if you wanted to, you could add
Yeah.
property.
Let's find out. I'm almost 100% certain, but let's say let's say title. What do you want to call our property? Our key. Color is equal to food. Oh, well, okay, let's try this. And then, oh, so we're not getting an error. That's promising. ABC color. Look, there it is.
Yeah.
Oh, there it is. Ta-da! So yeah, that's cool. I thought that makes sense. So let's see. This is live. This, what we have here, is a live document element, which means any changes that we make to this will automatically be reflected on the page. And that's going into setting data, which I think, talk about that. Setting data, okay, yeah. So the next thing to talk about is setting data. I'm actually going to clear this, and I'm going to do, there we go. So var title is equal to Control L, just like in the terminal. Document dot query selector. What is it? Title. And now I have my title right there. So title dot, what do we say? Text content. We'll print out the text, but I can change it. Whoa! And it'll change it on my page. That's kind of cool. That works because this is an object, and text content is a property of that object. And when I have a JavaScript object with a property, and I want to change that property, what do I do? Yeah, I just assign a new value to it, and that's it. It's nice and easy. All right. So if we go through the rest of this one index.js file, we can see this is doing basically the exact same thing, where I'm taking that title and I'm assigning a new value to it. It's a string, so we can concatenate it and assign a new value to it. So if I save this and I remove these console logs and come back and run it, we'll see it happens really, really fast, but the page loads and then runs our JavaScript, and our JavaScript gets this title and then changes the value of it. That's what's happening on line 44 and 45. So, and here we are. Here we are working with that style object that I was talking about. In CSS, you use hyphens to separate different words of style properties. In JavaScript, we camel paste them. So background dash color becomes background color. So I'm going to run this. We're setting a background color blue, a padding of two M's, a width of 100%, and a text align center. What's it going to look like? It looks like that. Cool. That's a little easier to read. Cool. How do we feel about all this? Pretty good? Great. So the next thing we're going to talk about is actually creating elements in JavaScript, which we can do. with the create element method on the document object. It takes a tag name, which in this case is A, but we could also do div, h1, something like that. We give it a link. Once I create it, it's just as if I pulled it off the page, except all of the data is empty because I haven't filled it in yet. So I can give it an href. Backslash means the current page, right? I can give it an ID, and then set the text of it. And then I'll print it out. And make sure I'm not printing out anything related to my title. Okay. So what we expect to see is that anchor element printed out here. And that's exactly what we get. Change the console.dir, refresh the page. Here's my link. You can see all the stuff inside of it. It's just as if we pulled it from the page. But it only exists in memory, right? Unfortunately, there's no way to add it to the page. Oh. No, there is. Of course there is. We do that through a process of appending. So what I'm going to do, let me break this out actually. So var first p equals document element by ID, and then first p append child. So up above, I have this link element that I created. I'm going to get this first paragraph from here, and then I'm going to use this append child method with my link. There it is. And it's a real link. You can click on it, and here I am, back at the root of my file system. That's kind of crazy. All right. So there we go. And then if I want to remove it, I can call this link.remove method. I guess I call this paragraph. We'll call these one at a time. Can't really see it there, huh? So if I do this and I refresh the page and I come here and this is the paragraph there. And if I do link, this is the link. Should be able to do link.remove, and it's gone. So I refresh the page and start over. I have my paragraph right there. I have my link right there. The other way I can do this is para.remove child link. And it's gone. You're dealing with a different node. So remove child is going to remove, we're trying to remove the child node of whatever element we're calling this method. So in this case, it's our paragraph. We're trying to remove the link, which is a child, because it was in this paragraph. Remove, we call on the actual method, or on the actual element itself. So here I could do something like para.remove, and it's gone. Cool. Okay. So I have a two folder with another index.js file. It's related to another index.html file here. The exercise is to dynamically generate a table of contents for this file. So if I actually open it up, open to index.html. Here it is. So here I have this file. It has a lot of lorem ipsum in it. So much so that my browser thinks the document is in Latin and wants to translate it for me. The assignment is to go through this text and pull out the headers and build a table of contents in this box. Do you guys think you guys can do that in like 20 minutes or more? If more, then it becomes homework. I'll check in 10 minutes. And I'll be walking around the room, checking in on everybody. But in index.js in the to folder, in the exercises folder, there's instructions on what to do, as well as like steps to follow.